All right, here is part 2 of this lesson. I left off with the radius r in part D. Again, in part C, we saw the area scale factor controlling the area from radius 1 to radius 3 to radius 10. Now, in part D, we saw that the circumference of a circle with radius 1 is 2 pi, and so we're using the linear scale factor. And so we saw, radius 1 was 2 pi, and so then radius 3 would have been 6 pi, because it's 6 times bigger. Our linear scale factor, sorry, radius 3, our linear scale factor was equal to 3. And so we get these that are 3 times bigger. Now I left off with, like I said, radius r. So again, if our radius 1 is 2 pi, our radius r, I feel like I'm spelling radius wrong. Nope, I'm just using it too much. If we have radius r, that gives me a linear scale factor of r, right? To go from 1 to r is multiplying by r. It's a linear scale factor of r. And so then we would have 2 pi, times your linear scale factor for the growth, and you would end up with 2 pi times r as your, if you had radius r. Now, the big thing that they have us do that in part C and in part D is they give us, by doing those two problems, we get the formulas. So like the area of any circle, so area of any circle, I should put circles up here. Area of any circle is going to be what we saw when we saw the area when it was r, or when we saw the radius was r. It was pi times r squared. Again, that r squared is because we were using the area scale factor. Circumference is what is circled above, and that is 2 pi times the radius. All right, and those two equations are one of the biggest things in geometry. The area of a circle, the circumference of a circle, and by doing this problem, we kind of discovered it on our own using linear scale factor and area scale factor. Now, I should say we'll move into problem 8.101. My hope is to get through the rest of the problems and the math notes in this one video to not take up all your time in your day looking at math lessons. All right, so let's move into 8.101. On to problem 8.101, the first thing it says is to read the definitions of radius and diameter in the math notes box for this lesson. So I'm going to go down there quick and just recap what they're trying to show us here. And so there isn't a very clear definition of what radius and diameter are in this math notes box, but most of us know that the radius is, if we look at it right here, it's from the center of the circle out to the side of the circle. And that would be our radius. So from the center just out to the side, and our diameter is just that whole length. All right, so the whole length here, if I try to show it, is what they'll call D, the diameter from one side of the circle all the way across the other side of the circle, and it's got to cross through the center. The important thing to note with this all is that the diameter is always twice the length of the radius. All right, so like in our circumference equation, and it even says it here, in our circumference equation, we use the circumference is 2 pi r, all right? That could be rewritten using diameter, and so instead of using 2r or 2 times r, you could just use d, or diameter, because our diameter is really twice the length of our radius. And so there are these different equations that you could use, and that's what they're just trying to highlight here. So if you want to use 2 pi r for circumference, or if you want to use pi times the diameter, just remember that 2r, like 2 times r, is different than r squared, so we cannot use the diameter in our area equation. Area's got to stay pi times r squared. Again, r squared, area scale factor. All right, 8.101. So we know these equations now, and so we can do these problems somewhat quickly. All right, so in A, it says find the area of a circle with radius 10. Well, we know the area formula now from the last problem. So the area formula is this pi times r squared. Well, they're telling me in part A that the radius is 10, and so I can just plug in 10 for my r, and I get pi times 10 squared, which gives me 100 pi. Not bad. Okay. Find the circumference of a circle. Well, we know that there's circumference, and I'm not going to write the whole thing because I just can't write on these things. So circumference I'll say is c, and we said that that is 2 pi times the radius, or I just said in the math notes that it's also just pi times the diameter. Either one works. If the radius is 7, the diameter is twice as long, so the diameter would be 14. You could use either of those to do this problem. But if we look at b, we're going to use that equation 2 pi r, or at least I am, and I'm going to say that, well, 2 pi r, let's plug in that we know our radius is 7. Sorry, our diameter is actually 7. So our radius would be 3.5. Our radius is half of that. But let's use the diameter equation if they're going to give us diameter. So instead of 2 pi r, let's use pi times the diameter. And let's just say, we know our diameter is 7, so we can just plug in 7 for d, and we get that that is 7 pi. Not too bad. If we did use 3.5 as a radius, it would have been 2 times 3.5 times pi, and 2 times 3.5 would have also been 7, so it would have still gave us 7 pi. All right, part C. It's saying we know the area of a circle is 121 pi square units. So what is the diameter? Well, the first thing we're going to need to do here is we're going to need to figure out what is the radius, and then we're going to need to figure out, or then we're going to need to multiply that radius by 2. And so we know the area of the, we know that the area of my circle is 121 pi, which means the equation, the formula for a circle, pi times r squared, is equal to 121 pi. All right, now we can solve this equation for r by just doing some algebra. So I can divide both sides by pi, and I just get r squared equals 121. To get rid of the squaring, you got a square root, and you just get that r is equal to 11. All right, but we're not looking for radius. We're looking for what is the diameter. Well, the diameter is always 2 times the radius, and so our diameter for this problem is going to be 22, because 2 times 11, our radius, is equal to 22. All right, so that one's kind of working backwards, where they're giving you an area, and you're going to have to, say that the formula is equal to that area and solve for the radius. And in that case, we have to solve for radius because we're using our area formula, which we cannot use diameter in our area formula. All right, the last one, if the circumference of a circle is 20 pi units, what is the area? So again, we're going to need to find out what the radius is and then go from there. But they're giving us a circumference, so we're going to have to use the circumference equation and set it equal to that. Our circumference equation can be 2 times pi times r, and that's going to have to be equal to 20 pi. Again, algebra to solve for r, and so I can divide this here by 2 pi. I can divide this by 2 pi, and I'm just left with the radius is equal to 10. All right, working with these pi's cancel out. People get kind of confused with pi, but pi is just a number, and it will just cancel out. Like if you divide pi divided by pi, they just cancel. And then 20 divided by 2 gives me 10. So now we know a radius, which means I can use my area formula to figure out what is the area of this shape. And again, my area formula for, I've said it a lot already, but it's pi times r squared. Plugging in our numbers, you get pi times 10 squared, which gives you, again, 100 pi. And there we have A, B, C, and D for problem 101. And we'll move on to 102 and 103. And then I'll just put up the math notes at the end so you can read them. And then we'll be done. Problem 102 is doing exactly what we did in 101, but now just a word problem. Again, this is a good one to pause the video and try to do it on your own. It's just like what we did, but now in a word problem. But I won't read the whole thing just for time reasons. But what it's saying is that this giant tree in the Sequoia National Park is so gigantic, in fact, that it has a circumference. The base has a circumference of 102.6 feet. Assuming that the base of the tree is circular, how wide is the tree? They're asking really, what is the diameter of that tree if the circumference of the base is 102.6 feet? Okay. How does this diameter compare with the length of your classroom? Well, I don't know how long our classroom is, and so we're not going to do that part. But we can do this part. We can say that if we know the circumference is 102.6 feet, well, we know the equation for circumference is 2 times pi times the radius that we do not know. But we know that gives me an answer of 102.6. Sorry for the little point there. Also, sorry for the terrible handwriting throughout the whole lesson. But now we can solve this for r. We can solve this for r and then multiply our radius by 2 to get our diameter. And so it's actually kind of a quick problem. What we need to do is we just need to divide both sides by 2 pi. And this becomes calculator work because it's not so nice with pi's canceling this time. So I got to get out my calculator here. If I do this calculation, I end up getting that the radius is equal to 16.33 feet, I believe, right? Are we working with feet? Yeah. 16.33 feet. Well, that's the radius. We need the diameter, so we need to multiply that by 2. So 2 times r gives me my diameter. And if I multiply this by 2, I end up getting 32.66 feet as the diameter of that tree. Now, if you can picture what our classroom looks like, maybe you can think like, well, what is 32.66 feet for our classroom? I don't have the imagination strong enough to do that, but I think that would take up maybe our whole classroom. All I know is that's ginormous for a tree. All right, we'll move on to the last one, 103, and then math notes, and we'll be done. So looking at problem 8, 103, we're going to investigate this pizza party. And with the time I have left, I don't want to rush through B, C, and D because it's kind of new information. And so I'm going to do part A in this video, and then I'll make one shorter video to explain B, C, and D. I promise as I keep going with these online lessons that I'll try to speed it up the best I can. I definitely can find some things to cut out. Maybe I won't need to ramble and talk as much. But in A, it's saying the goalie ate half of a pizza that has a diameter of 20 inches. What is the area of the pizza that she ate? All right. And then what is the length of the crust that she ate? And we're going to leave this in exact answers. Do not convert to decimal form. That one I don't care as much about, but we're going to investigate it. So since she only ate half the pizza, we're going to find the area and the circumference of the whole pizza, and then we're just going to cut that in half to figure out what she ate. And so they're telling me that the diameter is 20, which means that the radius is 10. That radius is important to finding the area. Okay, so the area of the pizza. Area is pi times r squared, which is pi times 10 squared, which is 100 pi. Now that's the area of the whole pizza. She only ate half of it, and so we need to cut that in half, which means we divide that by 2, and that tells me that the area of the pizza she ate was 50 pi. All right, now we also want to know the circumference. We want to know the circumference of the pizza she ate, which is 2 times pi times r. Again, our radius is 10, so you get 2 times pi times 10, which gives me 20 pi as a circumference, but that's the circumference of the whole pizza. She only ate half of it, and so we got to cut that in half, which means that the circumference of the pizza she ate was 10 pi. Now, I should make sure I put my units on this. It's inches, and so if you're talking about the area, that is 50 pi inches squared. And if you're talking about the circumference, that is 10 pi inches. To make sure this is clear, this is 10 pi inches because it's circumference, it's not inches squared. Area is the inches squared, circumference would just be 10 pi inches.